This is the infamous multibeam, and it's actually a fairly recent invention. It's an overgrown sonar. The basic idea is what they call a phased array sonar. And the way a phased array works is if you have two transmitters and you're halfway in between the two, no matter what the waves are doing, they'll constructively interfere, and it doesn't matter how far along that line you are as long as you're exactly in between the two. And that would work if you had 2, 3, 4, 5, it doesn't really matter as long as they're equally distant. But what if you wanted to steer the beam a little bit sideways? It's basically going to be a sine theta phenomenon, because what you're going to worry about is how much extra does the beam have to go from transducer 1 to 2 to 3, and it basically just depends on the angle that you're steering. If you're going to steer the beam off to the side, you need a little bit of a phase shift, and the key question is sine theta, because it's going to be this little extra distance along the beam. But there's tons of technical difficulties. And the first one is, how do you make that nice narrow beam? Well, there's two phased arrays, and one goes along the ship, and there's another one that goes sideways. And the way that it works is the one that goes sideways is not the one that lights up the bottom sideways, because it's basically like I don't know if you guys studied like geometric optics and stuff. You get a diffraction pattern, or you get an interference pattern in this case. So what they really do is they light up the bottom with the array of transducers that's going front to back, and if you phase things correctly, it makes a real narrow, sharp beam that goes sideways across the track of the ship. So this is called a Mills cross. So the transmit beam is front and back, and the receive beam is sideways. They've got 192 separate transducers are going across the ship, and each one is slightly different in frequency. It's basically from 11 kilohertz to roughly 12 kilohertz, and they sweep through that. And the reason you need to do that is, let's say that I ping straight down. Well, which one is going to get the signal first? You have to have a time tag, and the way they do that is they sweep through the frequency. So because they know they transmitted starting at 11 kilohertz and go up to 12, they can figure out which got transmitted first, which is received first. So that allows them to sort out the receive. It's basically as if you were coding by time each pixel on the bottom of the ocean that gets lit up. Then there's also lots of mechanical details that require that you have really good servos and GPS, because as you can tell, especially today, the ship's moving around. So if I transmit straight down right now, the ship could roll forwards or backwards, pitch and yaw and all this, and it actually goes up and down, which is called heave, right? So you have to have all these gyros and GPS and everything else to keep track of where the ship's attitude and position when you transmit, and then as it comes back, and of course this is constantly changing. So you've got to correct for all that.